everyone, welcome to Vedantu JEE English. I'm Diksha Ma'am, your chemistry master teacher, and students, in today's class we are going to do structure of atom. Today's class is day 4 of 5 days challenge, and in this we have already done chemical bonding, coordination chemistry, GOC, and today we are doing structure of atom, and tomorrow we are going to do electrochemistry. So what is the criteria of these sessions? So this session is going to be around 1 or 1.5 hour, right? And here we are going to cover the important chapters where I am covering the most important topics which are frequently repeated, right? And we will also tell you the sample questions that they ask you in the JEE latest questions that they have already asked, right? So let's start with the session without wasting any time. I have given all of these are my handwritten notes that I have made specially for you guys. So do hit the like button because all these things we are doing just for you, right? So let's see this, everybody. First is discovery of electrons. So if you talk about the discovery of electrons, in this case the questions are not exactly asked from discovery of electron, but you should know the base should be clear, right? So discovery of electron is done by a discharge tube. A discharge tube experiment has been done. In this, what you have is, you have cathode, you have anode. Cathode is negative, anode is positive, and what you will see that you have filled a gas here at very low pressure and very high voltage. And what will happen? Some rays will start traveling from cathode to anode, right? Because they are traveling towards anode, that's why they are negatively charged cathode rays. That's why cathode rays are negatively charged, and they consist of electrons. And what we have observed that these rays are invisible, they travel in the straight line. In the presence of magnetic field and electric field, they are deviated from their path. They are negatively charged and their E by M ratio is independent. It doesn't matter that whatever gas you take, always E by M ratio is going to be same, right? Then the charge, mass and E by M ratio is going to be this, that you must know. But ma'am, how exactly do we calculate the charge? Ma'am, how do we calculate the mass, right? So this is a very important experiment. Usually students skip this experiment. But from here I will show you how latest question in your JEE Mains they have asked from this particular experiment that students usually skip, right? That's why I taught you discovery of electrons, discovery of cathode rays. Otherwise it's not that important, but to understand this you must know that, right? Now let's see Millikan oil drop experiment, right? So what exactly we have done in this experiment? We have two chambers here. Now in this case we have connected it to cathode, this is negative, this is positive anode, right? And here we are spraying some oil drops, right? And here what you will see, right? Here you have X-ray, right? This is X-ray, and from here you have some particle which has electrons that is coming to this side, right? And I can draw it by white pen, right? Let's say this is that particle, right? And from this side you have oil drops that are coming from upside, right? And what will happen? This particular atom or charge, right? Whatever you have here, which has electrons in it, that will be caught up by the oil drops, right? So what you will see, you will experimentally, now this oil drop is here stationary, because what you will see that this particular plate that you have and this particular thing that you have here, this is also having gravitational force that is going downside. This is also having electrostatic force, because of which they are balancing each other, and this is remaining static, right? So now what kind of question they ask you is based on this simple thing, that is Q is equals to NE, right? Now I will little bit slow down, because still here now whenever things are quite important I will slow down myself, okay? Don't worry about that. Now this is Q is equals to NE, right? Ma'am, what is Q? Q, it's like you are a person and you have caught some a ball, right? A cricket ball you have caught. Now the total mass of cricket ball and you will define Q. So that means Q is the charge on that particular particle plus charge on the oil drop, right? So it may be n number of electrons in that particle. So the total charge that you will calculate experimentally, this will be calculated experimentally, right? And this one you will know that how many number of particles that you have, and this will be in, it was when he did experiment with various particles, what he observed that not various particles under different conditions, right, different times when he did the experiment, he observed that it is always coming out to be n number of 1.6 into 10 raised to power minus 90, right? If you see this, that is the charge of the electron. So how the charge was found out by the Millikan? He saw that this Q that he is calculating experimentally is always an integral multiple. That means this n can be 1, 2, 3 and so on. This is always coming out to be integral multiple of this particular quantity. That means this quantity is the charge of one electron. That means this quality is charge on one electron. And when you multiply, let's say in this oil drop you have 2 electrons. So it will be 2 multiplied by 1.6 into 10 raised to power minus 19. Let's say you have 1000 electrons in one oil drop. Then it will be 1000 multiplied by this charge. That means that fixed charge which is always going to multiply by some integer, and then you will have the charge on the oil drop. That is your charge on one electron, and that is how charge on the electron was calculated. Now if you see, we have the latest question of JEE Mains 2021 that says an oil drop of radius. Now see this question, very interesting. We are saying oil drop of radius 2 millimeter with a density of this, density is also given to you, okay, is held stationary under a constant electric field. Electric field is given to you, okay. I told you that that is static. The oil drop is static because of two things working on it. One is gravitational force, other is electrostatic force. These two things are working on it, right? So in the Millikan oil drop experiment, what is the number of excess electron in that oil drop will possess, right? This is what he is telling you. This is what he is asking you, right? See one thing here. We have 2-3 things here. First is, we know that electrostatic force. What is electrostatic force? That is charge into electric field. Like electric field is given to you. And charge, what is charge? Charge, we have already seen, charge is equals to number of electrons into charge on one electron, right? So you can say any capital E, where capital E is the electric field that is given in the question. That is given in the question. And this is the charge on oil drop. Charge on oil drop, right? And small e is the charge on one electron, that is this much, right? Now, I have also told you one thing, that the oil drop is not falling down here. Oil drop is static. Why? Because it has two forces that are opposing each other. One is electrostatic force that is defined by QE, that is NEE. And other is the gravitational force that is equals to mass into gravity. Right? Now, you will equate both of them because they are balancing each other. You will equate them. You will have NEE, mass into gravity. Gravity, you know, that's a constant. E, you know, this you have to calculate. And capital E also given in the question. Ma'am, what about mass, ma'am? Mass is not given. But we know that density is equals to mass by volume. So, mass is equals to density into volume. Now, if you see, volume, radius is given to you. So, volume will be 4 by 3 pi r cube, right? You put the value of radius here, you will get the volume. Volume into density is mass, right? That's it. This is what you have to do here. Mg, number of electrons is mg into E. This is given, mass will be equals to, this is volume, this is 4 by 3 pi r cube, this is volume, right? And this one is density, and this one is density. multiply them, multiply by gravity, E into E, put all the values and you will get your answer. Just take care of the units here, right? Just take care of the units here. You have to, like, here rho is given as 3 gram per centimeter cube, right? But we have put the values of SI units, we have put it here, right? Okay, that's how you will solve this and you will get your answer here, right? Now, next is, in the similar way guys, we have discovery of protons, that is done in the same discharge tube, but here what you have, in this case you have, again, this is a gas. Now understand one thing, in an atom you have electrons, you have protons. Right now you know that protons are in the nucleus, but at that point they had no idea about it, that protons are inside the nucleus. Right now you know that protons are inside the nucleus, right? At that time what they observed, that now if you imagine any atom, we know that protons are inside and electrons are revolving. So one electron you can take out, right? That's why cathode rays were having one electrons. But in case of anode rays, we know that you can't take out one proton from here. So that means when I talk about hydrogen, I will have one proton inside that nucleus. In case of helium, I will have two protons. In case of, let's say in case of nitrogen, I will have 7 protons. So that means you are not getting individual proton, you are getting a bag, like you have Lay's packet in which Lays are there, right? So you will have a bag in which the protons are inside it. You can't take out them individually, right? So that is not possible. That is why we are saying that the rays that we have from anode, from anode side, they are going to the cathode side, right? Firstly, because they are getting attracted to a negative electron, that's why they are positively charged. Then we got to know, actually these are not protons, actually these are gaseous ions. So whenever from a gas you take out all the electrons, the thing that you are left with is actually your anode rays, right? For example, in case of nitrogen, you take out 7 electrons, then you will have 7 protons, right? And that will be in a big nucleus, in a bag it will be. That is why E by M ratio is dependent upon the gas that you have taken. In case of hydrogen, you will have only one proton in one particular bag, right? In case of oxygen, you will have 8 protons, right? So that's how the number of protons in that bag are varying. But for electrons, one electron you can take out. They individually you can take out one electron. That's why we say E by M ratio is dependent on the nature of the gas. And here anode rays are nothing but they are gaseous ions. They are gaseous ions, right? They are gaseous ion. Okay, everybody, is that clear? They are gaseous ions. They are not proton. Only in case of, for hydrogen, H positive is equals to proton. In other cases, because in hydrogen you have one proton, one electron. You take out one electron, you will be left with one proton only. In other cases, it's not the same, right? Now, next is discovery of neutrons. In case of neutrons, guys, this is done by James Chadwick, and here you have basically this is a neutron that is inside the nucleus, but it will not have any charge. It has mass same as protons, right? So here how it is done, beryllium atoms, on beryllium atoms alpha particles are bombarded and you will have the elimination of neutrons from them. Till now not as such question they have asked, but because they have asked question on Millikan oil drop experiment, that was also unexpected for the students. That's why I have taken this as well. They might ask you question based on this as well. So now this one you should know, the charge on electron, proton, neutron, the mass of electron, proton and neutron should definitely you should know, especially the electrons, right? Now let's talk about atomic models. Now this model so just was the first model in which we know that okay, it's like a watermelon. So basically what we see that the red part of watermelon is the protons that are uniformly distributed, and the black seeds that you have are the electrons that are embedded inside the watermelon like structure that we call atom, right? But this model was a big failure because it was not able to explain you electrical, it was not able to explain that how chemical bonds are being formed, right? How the electrons are being embedded here, then how electrons are coming out of this watermelon like structure, and they are forming cathode and anode. This was very unexplainable by this Thomson model, right? Now next model that we have is Rutherford model. In case of Rutherford model, this is an interesting model. From here easy questions can be asked very easily, and this one is very interesting, right? So here what you have taken, we have taken a lead source which is a radioactive source from where alpha particles we will take out, and these alpha particles are going to bombard on the gold foil which is having very less thickness, right? So what will happen when they will bombard here, you will see three things here, right? What you will see that some of the alpha particles will move straight, right? Some of the alpha particles will move straight without any deflection, undeflected beam, right? Some of the alpha particle will scatter at certain angle, they will be deflected a little bit, right? And some alpha particle will be bounced back here. Some of the alpha particles are moving straight, some are deflected by an angle, some are just moving back. Right, these are the three conditions, these are the three observations that we had. Now, what is this circle? This is now because you can't see alpha particles. So that's why you will see the blinking on the fluorescent screen. That will tell you that okay, alpha particles has striked here. Now the things that you had, that you have seen here, that most of the atom is empty now. Why? Because see, if you have an atom like this, right, why most of the alpha particles are going straight? Most of the alpha particles are going straight because most of the space inside the atom is empty. That's why most of the alpha particles are moving straight. Now we are saying some of the alpha particles are deflected. That means there is something that is in the center which is very dense, right, which is very dense, but it is very small. It is occupying very less space, but it is very dense. So when some alpha particles that are passing near that, they are being deflected. They are passing near that, they are being deflected. And because this thing that you have inside, that is positively charged. Now how come I say this is positively charged? Because see, alpha particles are nothing, alpha particles are nothing but they are helium-2 positive ions. Helium-2 positive ion means they are positively charged, right? That is the reason, because these are positively charged. Now this must be positively charged, that they are getting repelled with each other. So that's why we are saying there is some positive charge inside in the center of the atom, which is very small, which is very dense. And when some alpha particle, they strike directly on that thing, it will bounce back, right? So like 1 out of 20,000 alpha particles are being bounced back. They are very less, right? So we are saying there is something positively charged nucleus, and Rutherford named this term as nucleus. None other than Rutherford, okay? He named that this positively charged thing is nothing but this is a nucleus, and a nucleus is very small, it is very dense. Electron revolve around the nucleus, right? Then he said that charge on the nucleus is going to be plus of ZE, right? Now why the charge is going to be plus of ZE? Because Z is the number of protons that you have and E is the charge on one proton. Neutron does not have any charge. And one thing to remember, when we talk about Rutherford, there was no talk of neutron. He had no idea about the existence of neutron. He only knew about the nucleus, right? That nucleus has protons. That's it, right? Radius of atom is 10 raised to the minus 10, and radius of nucleus is like 10 raised to the 5 times smaller than the radius of the atom, right? So this is 10 raised to the 5 times smaller, right? Now volume will be, this will be in cube, you cube it because this is 4 by 3 pi r cube, that will be 10 raised to power 15, right? Now let's see what are the drawbacks of Rutherford model. It says that Maxwell theory, right? Maxwell, what he explained, Maxwell said that whenever a particle that is in a circular motion, right? Now if you say it is in a circular motion, electron, we know that even if the speed is same, velocity is going to change because the direction is changing. That means this particular particle is accelerated. Maxwell theory says that whenever you have a particle that is in the accelerated motion, it will always radiate energy. So if you say this electron will always radiate energy, and according to that, this electron will fall into the nucleus. But we are made up of atom, we are stable, that means this also must be stable. So this theory has this limitation. Then second is, he was unable to explain about the line spectra that we have, right? And these are the two things that was not explained by Rutherford. Now this is a question of JEE 2021, a simple question. In the Thomson model of an atom was correct. The result of some, I am not only teaching you difficult one, I'll teach you difficult topics as well, but this is a scoring topic. If they ask you question from Rutherford model, it is going to be simple, right? So then the result of Rutherford gold experiment would have been all the alpha particles pass through gold foil without decrease in speed. Alpha particles are deflected. Now he is saying that correct, you have to, alpha particles are deflected over wide range of angles. All alpha particles are bounced back at 180 degree. Alpha particles pass through gold foil deflected by small angles and with reduced speed. Yes everybody, so answer is going to be D is the correct answer, that alpha particle does not deflect in a very large angle, they deflect in a very small angle with a reduced speed. So D is the correct answer here. Right, now we are moving towards other things, like we have electromagnetic radiation. So from electromagnetic radiation, firstly let's understand what is electromagnetic radiation. See, electromagnetic radiation, it has electric field, it has magnetic field, it has wave that is propagating in certain direction. So it's like this. So all of them are perpendicular to each other. If electric field is moving in this direction, magnetic field will be perpendicular to it, and the propagation of wave will also be perpendicular to it. So all the three are mutually perpendicular to each other, right? This is what we want to say here. And for this particular electromagnetic spectra is where they ask you directly the questions, right? Direct questions are asked from these electromagnetic spectra, that firstly like you have radio waves that has lambda maximum, then micro, then infrared, then visible, UV, X, gamma, cosmic, which has minimum lambda. And we know that lambda and mu are inversely proportional to each other. Lambda is the wavelength, mu is the frequency, right? And here in the visible region, what you have, in the visible region you have Vibgyor, right, where you can just remember one thing, you just remember lambda of red is maximum. So how you can write it here? If you want to write it here, it will be Vibgyor. If you want to write it in the format of lambda. So Vibgyor, this has minimum lambda, this has maximum lambda. Okay, understood? Now first thing you should remember the electromagnetic spectrum. Then guys, these are the formulas from where the questions, numerical questions are asked a lot from structure of atom. So first is lambda mu is equals to C, or you can see this formula, C is equals to mu lambda. Then 1 by lambda is nothing but that is wave number. This is nothing but this is wave number. Right, this is nothing but this is lambda, this is time period, this is time period. So frequency is inversely proportional to the time period, right? Then we talk about that we are moving towards dual nature, right? From here, what are the questions? This is not asked in chemistry, but you should know that wave nature, we see the support in physics, that we have interference, we have diffraction, dispersion, reflection, refraction, that supports wave nature. But there are some phenomena that we will study here, like black body radiation, photoelectric effect, right, that heat capacity, line spectra, out of which we will study these two in details. Line spectra also will study, hydrogen line spectra, right. But these are the things that supports particle nature of the electromagnetic radiation. So first is photoelectric effect. So in photoelectric effect, what we say, that you have a metal, right, and what you want to take out, you want to eject electron from here, and what you want to do, you want to have an incident line, that incident light that strikes on it, and it will eject the electron from the metal surface. This is photoelectric effect. Now we know that the light that is coming can have different wavelength. The light can be violet, red, orange, anything, right? Different wavelength will be there. And we also know that energy is equals to, this will see further, E is equals to hc by lambda. This is actually from Planck's quantum theory. We will study that as well, right? As of now, E is equals to hc by lambda, we know that, right? Now we know that that is also nothing but this is E is equals to h mu. Okay? We say that this is from Planck's quantum theory. We'll study about that, right? We'll study about that in black body radiations. Actually, I should have taught you firstly black body radiation, then this, but chalo, now I have started this, so I'll continue with this one. E is equals to h mu, right? Now here the energy that is coming is with some frequency. Let's say its frequency is mu. Now it is ejecting an electron from a metal. Now every metal has certain tendency of going out. Every metal has electrons that have certain tendency. So they will have a specific mu naught, right? So this is h mu naught. So this energy that you're giving from the incident light, that is h mu. The energy that the metal electron wants is h mu naught, right? Okay, it's like for example, you want to eat something, you want to eat pizza, right? So you have only 20 rupees, you are giving 20 rupees to the shopkeeper, but he is saying it's of 100 rupees. So now you won't be able to eject out pizza from the shopkeeper, right? So when you want to eject something from the shopkeeper, you have to give them the certain amount of money, right? So three things can happen. Either h mu can be greater than h mu naught. If h mu is greater, the energy that you are giving, you have 150 rupees, right? And he is saying only 100 rupees he needs. 50 rupees you have extra, and that extra will be your energy, your happiness. I still have money, right? So this way electron is ejected, but with kinetic energy, right? If you have h mu is less, now if you don't have certain amount of money, he is asking 100 rupees, you only have 50 rupees. Now you won't be able to eject the electron here. If h mu and h mu naught are equal, sometimes what happens, we have only 100 rupees and he is asking for 100 rupees. Now we are not left with any money. You're like, I have eaten the pizza, but I have zero money. So you don't have energy now. So electron is ejected, but energy is not there, right? So from here we have an equation that is h mu is equals to h mu naught plus kinetic energy, right? And here you can write it here. The kinetic energy is nothing but it is electron into stopping potential. To stop the ejection of the electron, we apply stopping potential from outside. So kinetic energy is h mu minus mu naught that you have defined. Mu is nothing but c by lambda. Mu naught is nothing but c by lambda naught. You put it here, c is common, and this is another way of writing this equation that we have written there, right? Now, in photoelectric effect, there are certain things that you must remember. Number of electron ejected is directly proportional to the intensity of the incident light. Because intensity will define the number of photons. If number of photons of the incident light are more, then the electron ejected will be more, because for each photon you have ejection of one electron, right? For each photon, one electron is ejected. Then frequency, if you increase or decrease the frequency of incident light, that cannot alter the number of photons ejected. Frequency will only alter the kinetic energy of the photon ejected. If your frequency, that means you are not using, while frequency means frequency of violet is more, right? If you are using violet, then kinetic energy will be more. If you are using red, then kinetic energy will be less, because the mu, the frequency of red is less as compared to violet, right? So the light that you are using, the wavelength that light has, according to that the kinetic energy of electron will be defined, right? Then guys, third is very important. Based on this they have asked you question. This is very important. That is, size is directly proportional to the work function. Ma'am, what is work function? This thing that we are saying h mu naught, this is called as mu naught, that w naught, that is nothing but this is called as work function, right? And mu naught is nothing but threshold frequency, lambda naught is threshold wavelength. So size is directly proportional to the work function. So if you say lithium and sodium, right, which will have more work function, wait a minute, which will have more work function? Sodium is going to have more work function here, right? Okay, everybody? Okay, now let's do a question based on this one that is asked in JEE 2022. Let's see what kind of questions they ask you. The minimum energy that must be possessed by photons in order to produce the photoelectric effect in the platinum metal. So minimum energy that must be possessed by photons, that means they are asking you value of incident light, that is h mu they are asking you, to produce photoelectric effect in the platinum. So we know that threshold frequency mu naught is this much, okay, h is given to you, right? Minimum means h mu will be equals to h mu naught. That means we are saying we don't need any kinetic energy, at least we want to eject the electron. So h mu is equals to h mu naught, so h will cancel, mu is equals to mu naught. So answer is going to be, wait a minute, minimum energy must be possessed by the photons in order to produce photoelectric effect, the threshold frequency of, and minimum energy. Achha, they are asking you minimum energy. Oh, then you will calculate the value of mu is equals to mu naught. So mu naught is nothing but 1.3 into 10 raised to power 15, right? Now energy will be equals to h mu, that is 6.6 into 10 raised to power minus 34 into this mu, and by that you will get your answer. You will multiply this and you will get your answer here, right? Okay. Calculation is your task, guys. In 1 hour lecture I can't do the calculations as well, right? Okay, so what my focus is to teach you various important topics and the kind of questions that they ask from there. Let's see a assertion reasoning question based on that, that is asked in JEE 2023. That is, in a photoelectric effect, the electrons are ejected from the metal surface as soon as the beam of light frequency greater than the threshold frequency strikes on the surface, right? So we are saying that in the photoelectric, the electrons are ejected from the metal surface as soon as beam of frequency greater than threshold frequency is struck. Yes. When the photon of any energy strikes an electron in an atom, transfer of energy from photon to electron takes place. Now, how does this actually work? Photon will transfer its energy to the electron, and that's how it will take place. So we can say, here it is saying when the photon of any energy we can't say, right, strikes an electron in an atom, the transfer of energy from the photon to energy, energy should be greater than the work function, that should be there, right? So we can say A is correct but R is not correct here. So the energy should not be, the frequency cannot be any frequency, it should be, the energy should be greater than the work function. Only then that energy transfer can take place, right? Now let's talk about black body radiation. Again, this is another topic that is completely ignored by the students. है ना? In this chapter you have various topics that are ignored by the students. And trust me, quite a simple questions are asked from here. So what you have here in black body radiation, what actually he observed that in a black body like an iron, right, what was happening, the color was changing from red to yellow to white to blue. That means the lambda here was decreasing as the temperature was increasing. As you were heating it, the lambda was decreasing and with the increase in temperature and frequency was increasing. Now he was unable to explain this, that why it is happening so, right? So what happened here, right? First thing is, I'll tell you the important points here. Experimentally, this was a graph that we thought will be correct one. We thought this is the expected graph. This is the expected graph. This is the real graph. Okay? Now, firstly, we need to understand one thing, that this explanation of this graph was given by Planck. What is that explanation? This all is not in your syllabus. So, I'll tell you only that part that is in your syllabus, right? Okay. So, what you need to understand here, he was unable to understand that why temperature and lambda are inversely proportional to each other, right? How come when you are increasing the temperature, right, lambda is decreasing, the color is decreasing? How come it is happening, right? So for that, when we observe the graph, this was the expected graph, the real graph experimentally was coming out to be this one. Firstly, they focused on the graph clarification. So graph clarification was given by Planck. Planck said that this real graph is the true graph. Reason being, energy is actually in the form of packets. Energy is actually in the form of h mu, that is the packet of energy, right? And h means Planck's constant, mu is the frequency, right? That's how we know that it is equals to nhc by lambda. That's why we know that energy is actually changing with the lambda, right? So Planck said that because this is the value of energy, that's how now what is the equation that he gave is not in your syllabus, right? You just need to remember that the clarification of this graph was given by Planck. He said that energy is in packets, and that's how he said that if you apply this formula, then you will get the real graph. How it is done, that's not in your syllabus. Just remember, black body radiation was quite confusing for the scientists to understand. Then this graph was even more confusing, that how come we are getting this kind of graph, right? Then Planck gave the answer for that, that energy should be equals to nh mu, right? It should be in packets. So Planck said that actually electromagnetic radiations are particles, and from that equation that Planck gave, the real graph scientists were able to get. So they said that okay, that means Planck's quantum theory is actually true. E is equals to h mu is actually true, and that's how we applied E is equals to h mu here as well. We applied E is equals to h mu here as well. E is equals to h mu here as well, right? Now after this what happened? Okay, now it was clear that this is the real graph. Okay, Planck gave the justification that this is the real graph of lambda with intensity. But who will explain? Now from this graph we are able to explain that how come with increase in energy lambda is decreasing. Actually lambda max is decreasing. This is lambda max. This is lambda max of that particular temperature. So this was given by Wien's law, that lambda max and temperature are inversely proportional to each other, and this is what you should remember for your exam, right? Lambda max and temperature are inversely proportional. What you will see here, if I say T2 is greater than T1, right, then I can say that lambda 2 max is less than lambda 1 max. Okay. Or let's say if this is not given, that T2 is greater than T1, then I'll say lambda 2 is less than lambda 1, that means T2 is greater than T1. right? These kind of questions are asked from black body radiation based on lambda max and temperature, right? Now let's talk about Planck's quantum theory, right? Chalo, before doing Planck's quantum theory, let's do a question that is based on, no, let's do Planck's quantum theory only first. Planck's quantum theory states that E is equals to h mu, mu is c by lambda, and lambda is nothing but 1 by lambda is nothing but it is wave number. So you have this particular formula, h is the Planck's constant, hc. Now these are shortcuts that you should know. Students only know this formula and they mess up in the exam because of the calculation. So these are the shortcuts that you should know. The value of hc you should know, that is 20 into 10 raised to minus 26. 1 electron volt is how much of joules? That is 1.6 10 raised to minus 19 joules. Now energy, this is also a trick, simple direct calculations that you can use. Energy, if you are calculating in electron volt and lambda is given in nanometer, then it will be 1240 by lambda. If lambda is given in Armstrong, it will be 12400 lambda. Now for example, lambda is given in meters. Convert it into Armstrong, then calculate the energy value in electron volt, right? Ma'am, if directly they have asked us in joules, then you can apply this formula as well, right? It's totally your choice. You need to see that what is given and how I can make the calculations easy. So I have given you all the shortcuts here, right? Now let's see this particular question, that is JEE 2023 question, that is based on the number of incorrect statements about the black body radiation emit or absorb energy in the form of electromagnetic radiation. Incorrect statements, how many incorrect statements? Frequency distribution of emitted radiation depends upon radiation. Black body radiation emit or absorb in the form of electromagnetic at a given temperature, intensity, frequency curve pass through maxima value. Maxima of the intensity versus frequency curve is at a higher frequency at high temperature compared to that of lower temperature. So we have to justify all these answers, right? So first is a black body radiation is an idealized physical body. So first statement is emit or absorb energy in the form of electromagnetic radiation. Yes, that absorb all incident electromagnetic radiation, and regardless of the frequency or angle of incident, it also emits energy in the form of electromagnetic radiation. So first statement is correct. Frequency distribution of the emitted radiation depends upon temperature. We have seen from the Wien's law that it depends upon the temperature, right? That is given by Planck's law. Planck's law said that it is true. Planck's law said that this graph is true, right? So that's why we will say that yes, frequency distribution curve depends upon the temperature. At a given temperature, intensity versus frequency curve pass through maximum value. We have seen intensity versus lambda is passing maxima, frequency will also pass maxima, right? Intensity versus frequency, also known as Planck's curve, does indeed pass through maxima value at a given temperature. At one temperature, you can see it is passing through a maxima. They are passing through a maxima here, right? Then you have the maxima of intensity versus frequency at a higher frequency, we know that temperature is inversely proportional to lambda, so it is directly proportional to mu. So at higher frequency you have higher temperature, that is also correct. So answer will be, all the statements are correct. So answer will be 4 is the correct answer here, right everyone? Next we have very important, that is Bohr model. Now from here you will see rest of the topics that I have done, right? Sometimes they ask you the question, sometimes not, but for Bohr model, though, they will definitely ask you 1 or 2 questions from that. One question though they will ask you, right? So Bohr model, right, valid only for one electron system, like you have hydrogen, you have helium positive, lithium 2 positive, right? All these things. Electron has energy of orbital. It says that the electron has that energy in which orbital it is staying. It does not have energy of its own. Electron loses or gain energy in the transition. For example, this is n is equals to 2, this is n is equals to 3. So when it goes from n is equals to 2, it will have energy of n is equals to 2. When it goes to n is equals to 3, it will have energy of n is equals to 3. So it can lose or gain energy according to whether it's going to a lower energy orbital or it is going to a higher energy orbit, right? Now, this is a very Hello, so sorry guys, I just lost that connection in between. I hope so now I am clearly audible and visible to all of you. Right everybody? Is that clear? Is that clear? Okay? Yes? So let's resume the session with Bohr atomic model. So if you talk about Bohr atomic model, in this case what you have, this is only valid for one electron system. That means it is valid for hydrogen, helium positive, lithium 2 positive, which has one electrons only, right? Electron has energy of the orbital. That means electron will be in that orbit. It will gain the energy of that orbit only. And if let's say this is n is equals to 1, this is n is equals to 2. If it jumps from one energy level to other, right, it will gain the energy of that energy level, right? For example, it is going from lower energy level to higher energy level, right? So it will gain that amount of energy. If it is going from higher energy level to lower energy level, it will lose that amount of energy, right? Now there are some important things from this particular theory. First is mv square is equals to 2h. This is exactly not a like formula, but one question has been asked in JEE related to this particular formula. That's why I have written it here, right? And next is this one, that is mvr is equals to nh by 2 pi. That is, this mvr is nothing but that is Bohr angular momentum. This is Bohr angular momentum, right? That is integral multiple of h by 2 pi. Now let's talk about the formulas that you have for radius, velocity and energy are very important. The formula of radius in terms of n and z, velocity and energy are very important, and energy and ionization energy are negative of each other, right? Then you must remember that if you talk about total energy here, right, total energy and kinetic energy are negative of each other, and total energy, potential energy is half of the total energy, sorry, double of the total energy, right? That you must remember. That's why I have written this simple thing here, right? Then you should know direct relationship, inverse relationship of radius, of velocity as well, of time period also. Frequency will be opposite of this, that will be z square by n cube, that also you must remember. And then the formulas, exact formulas of energy in terms of electron volt and joules, right? Now based on this we have some questions. Let's see that JEE 2025 question, that is radius of first excited state. So now whenever they say first excited state, that means you have to add 1 to the ground state. That means n is equals to 2 here. Helium means z is equals to 2, right? Now they are saying what is going to be the radius here. The formula of radius is n square a naught by z. This is 2, this is 2. You put all the values and you will get the value of radius here. That is going to be B is the correct answer here, right? Next question is JEE 2024 question, that is for a hydrogen atom, energy of electron in the first excited state, that means n is equals to 2, is this one. Total energy means this is total energy is given to you, TE total energy is given. Kinetic energy of the same electron, see guys, kinetic energy we know that is negative of total energy. So it is going to be positive of 3.4 electron volt, that is nothing but 34 into 10 raised to power minus 1 electron volt. So here you will put 34, that means answer is going to be 34 is the correct answer here, right? Okay. The next category of questions from here is calculation of number. This I will talk about later. Firstly, I will talk about this one. Firstly, for an hydrogen atom, when you put in the value of total energy, when you put the value of N for hydrogen atom, that is Z is equals to 1, you will get these values, and you will see here that when N increases, energy increases, and the gap here is decreasing. The gap here is decreasing, right? Okay. And you will also see the number of spectral lines in this case, right? So let's firstly talk about Lyman-Balmer only. Now, from N2 to N1, the electron is de-exciting, right? Now, we are fixing the value of N1 here. We are saying that if we say N1 is 1, that means all the lines that fall to N1 is equals to 1, that is Lyman, to N1 is equals to 2, that is Balmer, to N1 is equals to 3, Paschen, N1 is equals to 4, bracket, N1 is equals to 5, P-fund, right? N2 can be anything, and these series belong to a specific region. For example, Lyman belongs to UV, Balmer to visible, and Paschen bracket P-fund belongs to infrared region. Now let's see how to calculate the number of spectral lines here. Spectral lines are calculated by N2 minus N1, N2 minus N1 plus 1 by 2. And specific lines, if I say they have given that, they are not asking number of spectral lines. They are saying number of spectral lines between these N2 to N1, and you have to tell they are falling on a particular N1. I'll explain you this with the help of an example. For example, this question that is given to you for JEE 2024, that is the number of spectral lines obtained for helium-2 positive when electron make a transition from 5th excited state. That means N2 is equals to 6. Excited state, you will always add 1 there, right? 5th means 5 plus 1. First excited state means 1 plus 1. So N1 is equals to 2. So total number of spectral lines are N2 minus N1, N2 minus N1 plus 1 divided by 2. That is nothing but, you will say, that is 6 minus 2. 6 minus 2 plus 1 by 2. If you answer this, this will be 4 into 5 divided by 2, that is nothing but 10. So from N is equals to 6 to N is equals to 2, in total you have 6 spectral lines. But if they say, if calculate from 6 to 2, they are saying from 6 to 2 the transition and say the line belonging to Lyman series. That means it will be N high minus N specific. N high is 6, N specific means here N is equals to 1. That means 1. So total out of these 10 lines, 5 lines are coming to Lyman series. In this case, how many lines are belonging to Balmer? You'll put N high as 6, N specific as 2, 4 lines are belonging to Balmer. Let's see how many lines are belonging to Paschen. 6 minus 3, that is 3. 4, 5, 6, wait a minute. So, wait a minute. No. Lyman will be 6, right? Lyman is equals to 1, right? So, there will be 3 lines that are belonging to Paschen as well here, right? Okay, out of these all lines that you have, some will belong to Lyman, some will belong to Paschen, some will belong to bracket, some will belong to P-fund, right? Okay, so accordingly you will have your answer here, right? Okay, so now let's talk about maximum number of spectral lines are going to be 10. Out of this, some will land to Lyman, some to Balmer, some to Paschen. According to that, you will have your answer. Okay. Now let's see this one here, right? That is. Let's see this one. Here it is. We are saying Rydberg equation. This is the Rydberg equation, where RH is the Rydberg constant. It has the value of RH and the value of 1 by RH. Both you should know to make the calculations easy. This is 1 by lambda. This is wave number. That is RH Z square. Z is the atomic number. 1 by n1 square minus 1 by n2 square. n1 you can calculate from Lyman, Balmer, Paschen, or they can directly also give you that, right? But ma'am, how do we calculate the Balmer? Ma'am, how do we calculate n2? So for n2, what you have to remember, that if they are saying first line, it is n2 is equals to n1 plus 1. For second line or beta line, it is n2 is equals to n1 plus n2. For third line, n2 is equals to n1 plus n3. If they are saying last line or limiting line, n2 is equals to infinity. Now, when you are just one energy level above, that means energy is minimum. So, minimum energy, minimum frequency, or maximum wavelength or longest wavelength also can be written there. Or for n infinity, where energy is maximum, they can also write maximum energy, maximum frequency and minimum wavelength or shortest wavelength there, right? Okay, and if you see, the limitations are, these questions are also asked, that Bohr model was not able to give you that why there is splitting of spectral lines in the form of in the presence of electric field, that is Stark's effect, splitting of spectral lines in the presence of magnetic field, that is JEE Mains effect. He was not able to explain multi-electron system. He was not able to explain the duplet and the triplets that it was forming. And chemical bonds, why there is need to form chemical bonds, he was not able to explain all of that, right? Now let's see a numerical based question based on this Rydberg equation, that is the shortest wavelength, that means energy, we know that that is maximum, that means here n2 is infinity. Hydrogen atom means Z is equals to 1 here. Lyman means n1 is equals to 1. For lambda, this longest wavelength means n2 is equals to n1 plus 1, and n1 is given here to be 2. So here n2 will be equals to 2, right? And here lambda will be helium positive. What you have to do here, put the value in the Rydberg equation for both of them, n1, n2 and z value. Then divide it, this will be cancelled, solve this value and you will have the relation of lambda, helium positive and lambda, and that's how you can easily calculate your answer here. Then guys, we have de Broglie's equation that actually tells you the dual nature. It says lambda can also be, which is belonging to the wave nature, and this momentum that tells you the particle nature of a wave. Both he gave an equation which has both wave nature and particle nature, that is dual nature, right? So lambda is equals to h by p, that is h by mv. mv is nothing but under root 2 mke, and that is under root 2m q into vs, right? So for nth orbit, what you have, 2 pi r is equals to n lambda. 2 pi r is what? 2 pi r is actually, we are saying that this is the radius, right? Okay, so 2 pi r is the circumference if you take the particle nature, and if you take the wave nature, n number of waves can be there, right? So we say 2 pi r is equals to n lambda, which will give you 2 mvr is equals to nh by lambda. That gives you the equation of Bohr angular momentum. Then there is Heisenberg uncertainty principle, which is only valid for microscopic, very small particles, right? Because for very small particles only it is valid, so for us it is not valid. So you can measure my velocity and position at the same time, but the position and velocity of a very small microscopic particle like electron cannot be measured. You can only measure the uncertainty in position or momentum, or in position and velocity, and these are the relations, right? Let's calculate, let's see some questions based on this, guys. First question is frequency of de Broglie wave of electron in Bohr first orbit of hydrogen atom is this. They are saying frequency of de Broglie wave. De Broglie wave means lambda is equals to h by mv. You have to calculate 1 by mu here, right? Okay, you have to calculate 1 by mu. This you have to calculate. So you can say 1 by mu. Mu is equals to nothing but 1 by lambda. Lambda is equals to h by mv. Lambda is equals to h by mv. ठीक है? Okay. What else is given to you? What else is given to you? Achha, we know that mv square is equals to RH, right? We can do one thing. Let's see this thing. We know that lambda is equals to h by mv. When you multiply this lambda into velocity, when you multiply and divide it by velocity, then this will become nothing but frequency, right? Lambda by velocity. We know that velocity is equals to mu into lambda. So velocity, lambda by velocity becomes frequency. So we have written frequency here. This is velocity square. This is h by mv. So we can say frequency is equals to mv square by h. That is nothing but 2RH. You put the value that I have already given you in Bohr atomic model. This is a very good derivation, right? 2 into RH. Put the value of Planck's constant. RH is given to you and you will solve the answer here, right? And you will get to know the answer. Now you have to tell the nearest integer, right? This is given to be 10 raised to power 13. This is 660. So you can say nearest integer will be 661 will be the correct answer here. Because this is 660.06, right? This will be something greater than that. So that's why answer will be 661 will be the correct. Nearest integer you have to tell. Okay. Then the next question is, beta, this I hope so this is clear. This is just a derivation here that we have done, right? This is just a derivation here that we have done here, right? Okay. Chalo. Now let's see this. Nearest integer will be this. Okay, this we have done. Based on Heisenberg, this is based on Heisenberg uncertainty principle. The uncertainty of velocity of electron in the velocity of electron is found to be within atomic nucleus of diameter this. That means uncertainty in the position is given to you. Okay. Now they have asked you the uncertainty in the velocity. They have asked you mass is given, h is given. What you have to do, you know this formula. This is the formula. Delta x multiplied by delta v is equals to h by 4 pi m. H you know, 4 you know, pi you know, 3.14. Mass you know. Delta x value is given to you. Put all the values here and you calculate your answer here. Right? Now calculation is a tough task here. In 10 raised to power 9 you have to calculate the nearest integer here. Right? Okay? In 10 raised to power 9 you will calculate the nearest integer in terms of meter per second and hence you will get your answer here. Okay? Now let's understand quantum model. Right now, based on quantum model, a lot of questions are asked from structure of atom. You will see for yourself. I have only taken some sample questions, right? So it is divided into basically two parts. One is, we'll see that what is N, L, M, N, the formulas of that, what kind of questions are asked from that. Then we will see based on radial notes and based on the graphs, what kind of questions are asked. Okay. So quantum mechanical model has this equation, that is your Schrödinger wave equation, that is in a simplified manner it is written as h wave function into E wave function. H is Hamiltonian operator, E is energy, right? But these are actually in physics mostly. I don't think so in physics you have quantum mechanics now, but this is of higher level that you don't have in your syllabus. For your syllabus, all you have to understand is there are two kind of values, real and imaginary. In real values, you talk about nodes and then you talk about shapes. In quantum numbers, there are also the real values in which we talk about N, L and M. Now, important part to understand here is that Schrödinger has solved this particular equation. He solved some real values and those real values gave you quantum number and nodes, right? First, you will focus on quantum numbers. Remember that spin quantum number is not a solution of Schrödinger wave equation. This statement based can be asked to you that spin quantum number I have not written here. Principal, azimuthal and magnetic quantum number are the solutions of this Schrödinger wave equation, Now let's talk about this one, guys. Line is little tilted here, but let's focus on the formulas. First is principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Principal quantum number, we talk about the shell. It's like a address you are talking about. So in address, what we write? Firstly, we write the city name, then what is the society name, then we write the house number, right? This is how we write, similar way, right? So firstly shell, then subshell, then orbital, then you have rotation of the molecule, whether it's clockwise or it's anti-clockwise in that particular orbital. When you talk about shell, that is actually what Bohr called orbit. He calls it quantum number, we call it shell. In a shell, that defines the size or the energy, the values can be from 1 to infinity. Azimuthal quantum number, that defines a subshell, the sub part of the shell. The values will be from 0 to n minus 1, right? If you say n is equals to 3 here, the values will be from 0, 1, 2. These will be the values. And always remember 0 belongs to S, then 1, then 2, then 3. 1 belongs to P, then D, then you have F. Because these all you must have heard so many times. So S, P, D, F, 0, 1, 2, 3, these are the subshells. Each subshell will have specific orbitals, right? So M is the magnetic quantum number that defines the orientation, that defines the number of orbitals that you will have in a particular subshell. Like S has a specific shape, P has a specific, D and F, they have specific shapes. So azimuthal quantum number is defining the shape, right? This is defining the orientation. For example, for L is equals to 1, you have M is minus 1, 0, plus 1. That will be Px, Py and Pz. That means it is defining whether it will be on the x-axis, y-axis or z-axis. That is nothing but orientation, right? And spin quantum number will always be the clockwise or anti-clockwise rotation, that is plus half or minus half always, right? Now to calculate the number of shell, you have n. Number of orbitals in a shell is n square. Number of electrons in a shell is 2n square. This all we are talking about inner shell. We are talking about when we talk about inner shell. Then if you talk about a subshell, if you have to calculate that in a subshell how many orbitals are there, that is 2l plus 1. How many electrons are there, that is 2 into 2l plus 1, because in one orbital you have only 2 electrons. One will be clockwise, other will be anti-clockwise. Then angular orbital momentum is under root L plus 1 h by 2 pi. Spin, you will put the value of spin here, s plus 1 h by 2 pi. Right, let's see what are the kind of questions they ask you from here. JEE 2020 question, that is for an electron 2s and 2p. Now guys see, 2 means n is 1, s means l is 0. 2 means n is 1, L means S is 0. Sorry, P means L is 1. Okay. The orbital angular momentum. What is orbital angular momentum? That is under root L plus 1. Because here L is 0, so orbital angular momentum will be 0. Here it will be under root L plus 1 h by 2 pi. That is under root 1 plus 1 h by 2 pi, that is under root 2 h by 2 pi, right? So here answer is going to be 0, 0 and this B is going to be the correct answer here, right? You just have to put in the values, that's it, right? Okay. Then the filling of the electrons, how the filling of the electrons is done. They can also ask you, I have just given you question on one formula. They can also ask you how many electrons are in a shell, that is 4s. How many electrons are in a shell that is belonging to n is equals to 4. For n is equals to 4, how many electrons will be there? 2n square, that is 32 electrons will be there. Okay, that's how you will answer all of that, right? And always remember here, n can never be equals to n. Okay, if n is 1, L can never be equals to 1 because L is maximum value of L is n minus 1, right? And the value of m will always lie from minus of L to plus L. So if they ask you which of the following orbital does, which of the following sets of quantum number will not exist, you will tell from these values. You should know these values. From there you will tell which of the following sets will not belong, right? Now let's see how to write down the electronic configuration. First is of-Bohr principle. It states that n plus L rule. That means more is the value of n plus L, more will be the value of energy. That's a very, very important rule, right? And for hydrogen atom, n value more, energy more. That means 2s and 2p will have same value for hydrogen atom. Okay? Understood? Yes. Now, always remember more is the value of n plus L, more will be the energy. If n plus L is same, this is written here, right? Okay, this one, wait a minute, it should not be written for hydrogen atom. For hydrogen atom, if n value is same, then energy is same, right? This is for hydrogen atom. But except for hydrogen, n plus L greater, energy is greater. If n plus L is same, more the value of n, more will be the value of energy, right? So if you see, if you write the trick here, just write S, P, D, no, just write firstly S, P, D, F. Firstly, you have to write SS, then PS, PS, then DPS, DPS, then FDP, PS, FDP, PS. Right? SS, then PS, PS, then DPS, 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 then FDPS. Right? FDPS. This is the energy level diagram that you don't need to remember. Just remember SPDF. Okay? SS, PS, PS, DPS, DPS, FDPS, FDPS. Now write down 1, 2, 3, 4. This starts from 1. 1, 2, 3, 4. This is 5, 6, then 7, then you have 8. Then P. This is P starts from 2. 2, 3, 4. Then you have 5. Then you have 6. Then you have 7. D starts from 3. This is 3, 4, this is 5 and this is 6. Then F starts from 4. F starts from 4. 4, then you have 5, yes. And that becomes your increasing order of energy, and the electrons are filled in the increasing order of energy. First you will fill the electron in lowest energy level, then you will go to the higher energy level. Hund's rule states that first you will fill all the electrons in the degenerate orbital. Let's say you have P. First you will fill all the electrons in the degenerate orbitals that have same energy. Then fourth electron will be filled. Then the pairing will start. Okay, that is Hund's rule. Pauli exclusion principle says that in one orbital you can only have 2 electrons, that too with opposite spin. That is called as Pauli exclusion principle, right? Let's see a question based on that. Consider a ground state of chromium. How many electrons with azimuthal quantum number L is equals to 1 and L is equals to 2? That means this is for P and this is for D you have. Chromium is 24, right? That is nothing but 1s2, just write the electronic on. 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. That is the exceptional electronic configuration of chromium. Because of half filled electron, one electron will jump there, right? Now if you see this here, in this case S is 2 plus 2, no, S they are not saying, they are asking P. P is 12, P is 12, then you have D. D is 5 electrons. So answer will be B is the correct answer here. Right everybody? Now shape of the molecules. This is given by azimuthal quantum number. Right? This is given by azimuthal quantum number that states that, just give me a second, that states that this is S orbital, P orbital, D orbital that has spherical, then P, it's a dumbbell shape, D orbital has a double dumbbell shape. Shape of orbitals dxy, dyz and dzx are between the axes, and shape of dx square minus y square is along the axis, dz square has along z axis with a cloud that is there, right? Okay. Then let's talk about question that is entirely based on the shape. Asked in 2023, that is number of given orbitals which has electron density along the axis is. Along the axis, guys, along the axis will be these, right? Along the axis will be these. Okay, so number will be 5, right? So how many? Dx square minus y square, px, py, pz, they all have along the axis, and this is asked in JEE 2023. So you can see, you should go through these concepts. From these the questions are asked, and very simple questions are asked here, right? Now the last topic that we have here, right? So guys, firstly you should know the calculation of nodes here. Radial or spherical node is n minus l minus 1, angular node is equals to l, and total node is n minus 1. Now all these orbitals will show 2 nodal planes, but dz square show you no nodal plane. That is a fact that you must know, because in factual questions they can ask you that. Now if you talk about 3 category of graphs we draw, and let's see the rules that I have for. Radial wave function graph are between wave function and radius. This is radial probability density is between psi square, that is wave function square. This is wave function square multiplied by 4 pi r square dr. Okay, so these are the 3 graphs that we have, right? And all you have to go through is these rules to do the questions of these graphs, okay? Yes, everybody, let's do that, right? So rules are that always you have a graph of wave function that will always be positive and negative. That means it will always positive, negative, positive like this. And the graph of psi square and 4 pi r square dr psi square will always belong to only positive axis, right? That is the first 2 rules. Then there is, for s orbital, psi and psi square will start from maxima, right? Rest of the things will start from minima, right? For s orbital, psi and psi square start from maxima. Then third graph will start from minima. For p orbital, d orbital, always the graph will start from minima. Always and always and always. This is very, very, very important. Then psi and psi square peak will decrease. 4 pi r square psi square peak will increase. That means here it will be peak will decrease. Here the peak will increase. Okay? That's how the graphs will look like, right? Let's see. One is here now, graphical based questions are very important, right? Okay. Trends are that they can ask you these questions is JEE 2026 for sure, right? So if you see 1s, the graph between psi and psi square, if you see, that psi and r will be a simple graph, right? It starts from maxima for s orbital. Psi and psi square will start from maxima, and 4 pi r square psi square will start from minima. You just have to calculate the number of radial node, that is here L is equals to 0, N is equals to 1, that will N minus L minus 1 will 0. That means no radial node is there, and radial node is not the original point and the maximum point. You will calculate the in between point where x axis is 0, right? So this point is not radial node. This point is not node. This point is not node. This point is not node, right? First and the last point can never be the nodes, right? Okay. Last point, because node is defined that if you say you have an ocean is not a node because you will not fall into the ocean. But in between the roads, if you have gaps, that is the node that you have. So you are walking on a road and you have a gap here. You are walking on the road, you have a gap here. These are nodes. Then you are walking on a road and this is a big ocean. So this ocean is not a gap. This is not a node. These are the nodes. So in the end or in the starting, if you have any node, that does not belong to a node. Okay, that is the starting and the final point. Right? Okay, just give me a second. Hello, yes. So now if you see for 2s, you have how many nodes? 2 minus 0 minus 1, 1 node. So that's why psi is always, that means wave function for psi it is always starting from maxima. Here it is starting from maxima. It is positive and then negative, right? And this is your radial node. This is your radial node, right? Here this is the radial node. Here this is the radial node. If you see here, peaks are decreasing. Here peaks are increasing. Here peaks are decreasing, right? These two are starting from maxima. This one is starting from minima, right? Do you get it? So similar to that, we can calculate other nodes as well. Then we have JEE 2023 question that is based on wave function of 2s is given by this one. Radial node is formed. Node is when the value of this psi becomes equals to 0. This whole value has to be equals to 0. When you put this whole value equals to 0, this will be 0, this will be 0. See, this cannot be equals to 0. This is a digit value. This cannot be equals to 0. Either this can be equals to 0 or this can be equals to 0. So I'll put these two values as 0. That is 2 minus R naught by A naught is 0. That means R naught is equals to 2A naught. So at this value, you will have a radial node here. That was a very simple question. Then the next one is, which of the following about an electron occupying 1s electron in the hydrogen atom is incorrect? Okay? Incorrect you have to tell. Which of the following about the electron occupying 1s orbital in hydrogen atom is incorrect? The probability density of finding the electron is maximum at the nucleus. At the nucleus of finding the electron is maximum. At the nucleus, is it? They are asking the incorrect one. The total energy of the electron is maximum when it is at a distance A naught from the nucleus. Right? So total energy of the electron is maximum when it is at a naught distance. The electron can be found at a distance 2a naught from the nucleus, right? 1s orbital is spherically symmetrical. 1s orbital you have that is spherically symmetrical. So you can say probability density is maximum at the nucleus, right? That is correct here because they are asking you probability density here, right? That is maximum at the nucleus if you talk about occupying in 1s orbital, because in 1s orbital that is a spherical. If similarly they ask you for a p orbital or a d orbital, probability density nearest to nucleus will be 0. That's why for 1s orbital, if you see, that's why for 1s orbital psi and psi square start from maxima. That means probability density at the nucleus has maximum, maximum probability of finding the electron. Electron can exist up to infinity from the nucleus. Yes. Now next is the total energy of the electron is maximum when they at a distance this from the nucleus. Electron can be found at distance this. 1s is a spherically symmetrical orbital. So we can say the total energy of the electron is maximum when it is at a distance a naught from the nucleus. That we can't define whether it's correct or not because we don't have that much information regarding that. So that's why answer will be B is the incorrect answer here. Next is the calculation of number of nodes here. N is equals to 3, L is equals to 2. So N minus L minus 1, that is 3 minus 2 minus 1, that is 0. Wait a minute, N is 3, SP 0 1. Nee, L is 1. So sorry. L is 1. L is 1 minus 1, that is 1. So answer will be 1 is the correct answer here. That is your radial node. Direct question that they have asked in JEE 2025. Right? Okay, so guys, that's it for today for structure of atom. And tomorrow we are going to do electrochemistry and we are going to pick up, I'm going to pick up some really important questions, some really important topics from electrochemistry, right? And I'll see you all at 7 p.m. tomorrow on this channel, and do let me know in the comment section if that is clear, if because you know something big is coming day after tomorrow, that is 5th of November, right? JEE 2026 high weightage crash course we are going to launch. right, where we are going to teach in such a manner. Here though I have taken in 1 hour, I have completed the full chapter, but there at a slow pace, I'll complete the most important topics with the sample questions, and we will also give you some sample questions for your homework so that you can practice on your own. The same kind of questions we'll do in the class itself, right? So more details will be there on 5th of November. So hit the like button, the link is in the description. Go and hit the like button for the crash course that we are going to launch, right? So everybody, bye bye, and do write it down in the comment section, hashtag Sigma crash course. Bye bye everyone.